Right now, in 2026, millions of homes across cities like this are firing continuous streams of data to servers hundreds of miles away just to perform basic daily tasks. But when you walk into a dark hallway and you have to stand there for 2 full seconds waiting for a remote server to authorize your light bulb, the illusion of a smart home completely breaks. The industry built its foundation on this cloud-first model. Offloading the computing power to massive data centers allowed companies to sell cheap hardware that could still control your locks, thermostats, and lights remotely. Voice assistants made this architecture the global standard, but that convenience came with unavoidable network latency and the constant transmission of your private household audio and data to third-party servers. Cloud computing successfully connected our houses to the internet, but structural delays and total reliance on an active connection prevented those homes from achieving true intelligence. To address these delays, hardware manufacturers are increasingly embedding computing power directly inside the house, a concept known as Edge AI. This chart maps the landscape, plotting internet reliance against local data privacy. Cloud devices sit high on internet reliance, with low privacy. Pure Edge sits opposite, no internet, data locked down. Between them is hybrid, balancing speed with selective cloud coordination. Direct. The underlying architecture you choose dictates exactly who owns your data and how quickly your house responds to your presence. Let's evaluate the cloud-first approach. Because all the heavy lifting happens in external data centers, manufacturers can sell you the actual devices for next to nothing. This matrix breaks down the 4 metrics that dictate the daily experience: latency, privacy, cost, and offline reliability. With the cloud, low initial cost buys access to massive computing power for complex voice queries, but if your internet goes down, your house goes dark. The real trade-offs are the physical limits of network speed, causing unavoidable 50 to 200 millisecond delays, and the mandatory subscription fees that now average between $120 and $240 every single year. A cheap cloud camera is essentially a subsidized terminal. You pay the true cost through perpetual monthly fees and by surrendering your behavioral data. The Pure Edge approach removes the server entirely. These devices are built with embedded neural processing units, meaning they execute complex AI tasks using their own internal hardware. Instead of a dummy terminal, the hardware you purchase acts as an independent, localized brain for your living space. Because the computing happens on-site, a motion sensor can trigger a lighting routine instantly. There is no round trip to a server in California to verify that you just walked into your kitchen. The trade-off here is strictly physical. Putting computing power inside the device pushes upfront costs to the $300 to $500 range, and your total storage is capped by the memory physically installed on the board. Looking at the matrix, Edge flips the cloud model entirely. You get response times under 10 milliseconds and zero internet reliance, but you pay a steep hardware premium. Edge architecture forces you to pay upfront for absolute data sovereignty and the eradication of false alerts, because the camera processes imagery locally before deciding to ping your phone. The hybrid architecture blends these strategies. It uses local processing for time-sensitive or highly private actions, while leaning on the cloud purely for long-term video archiving and heavy analytics. This is driven by federated learning. Your devices share anonymous, encrypted insights with the cloud to improve the collective AI, without ever exposing your raw personal footage or audio clips. Setting this up requires effort. You need a careful network topology using protocols like Matter and Thread, and you have to manually audit your cloud permissions to ensure the split works correctly. But on the matrix, hybrid balances the scales. You absorb a moderate initial cost to achieve optimal latency, while maintaining strict control over what leaves the house. If you are willing to manage the configuration, hybrid offers the localized speed of Edge with the scalable intelligence of the cloud. This decision tree maps architectural choices to the primary friction points in your home. If optimizing for long-term budget, choose Edge. Spending $300 upfront to eliminate monthly cloud fees means your system breaks even in roughly 18 months. Then the hardware pays for itself. For caregivers, analyzing subtle movement patterns locally allows the system to accurately detect falls without ever streaming raw video footage to external servers. Edge and hybrid systems provide necessary medical safety alerts while completely preserving resident privacy. And if you want performance, moving rules to local NPUs kills the voice assistant delay. When you speak, the room reacts instantly. Building a system specifically to eliminate your unique household friction provides the most long-term value. The technical capability to operate a living room without remote servers is now a practical reality. Modern hardware now guarantees secure local pairing and device grouping, entirely bypassing the need for cloud intervention. It comes down to a basic financial choice. Buy intelligence upfront by investing in local hardware, or you can rent it forever through subscriptions. By cutting the cord to the data center, the smart home finally earns its name, not by exporting your daily routine, but by keeping its intelligence exactly where it belongs, securely inside your house.